Welcome back to Mrs. Bailey's Math. We are in AP Pre-Cal and we are going over our notes for topic 1.11 on equivalent representations of polynomial and rational functions. All right, as you recall, h of x equals a polynomial of f of x over g of x if g of c equals 0. Then h of x has the vertical asymptote at a whole at x equals 0. Now, so for example 1, we are going to write an equation for h of x in factored form and find any values of x where h of x has a whole or a vertical asymptote. All right, first we need to do factoring. So for h of x, how can we factor the numerator? Remember, differences? Excellent. X plus 2, x minus 2. All right, in the denominator, we need to find two numbers to multiply to give us 10 and add together to give us 7. So what two numbers will that be? X plus 2, x plus 5. All right. So, from this factored form, what can we take away from the numerator and the denominator? X plus 2. So our factored form left is x minus 2 over x plus 5. Because x plus 2 was taken away, we have a whole at x equals negative 2. Do I have any questions on that? All right. Where do we have a vertical asymptote where the denominator equals 0 but not the numerator? At negative 5, x equals negative 5. Do I have any questions on that? All right, now it asks for us to find the domain of h of x for example 1. So we know that we have a whole at negative 2. We know we have a vertical asymptote at negative 5. So we need to make sure that we stop in those positions, those locations. So from least to greatest, we're going to go from our domain of negative infinity to the first stop at negative 5, and from negative 5, where is our vertical asymptote is at, until our next stop at negative 2, where our whole is at, and from negative 2, from where our whole is at, to infinity. Any questions on that? Yes, ma'am? I'm sorry? Sure. Mm-hmm. While I'm leaving it at this one, please go ahead and look at example 3. I want you all to go ahead and factor k of x, numerator and the denominator. You got it? You want me to move forward now? You good? Got it? Okay. Anyone has this? Okay. No? Yes? Oh, you still writing? Okay. All smiles here. All right, everyone got this that's already on the board? All right, we're going to go ahead and move it down. No problem. Oh, I'm sorry. Did you need it? Okay. All right. Let's for another fun activity. Let's factor example 3. Yay. So we need two numbers to multiply to give us negative 12, add together to give us negative 1. What values did you use? Negative 4 and positive 3. In the denominator, what can we pull out of all of these terms? An x. All right, and when we pull out an x, we have x squared plus x minus 20. We need to factor the denominator. Two numbers to multiply to give us negative 20, add together to give us 1. Negative 4, positive 5. All right, so we're going to put all the factored forms. X minus 4, x plus 3, x by itself, we have x minus 4, and x plus 5. Yes, do we have a whole? Yes, we have a whole at x equals 4. That is all right. Do we have any zeros? Now, in order for us to have, when we talk about zeros, we're not talking about vertical asymptotes. Vertical asymptotes is when we have a zero in the denominator. As far as a zero, we're talking about a zero in the numerator that doesn't cancel out in the also in the denominator. Negative 3. Because we canceled this out and we got a 0 up here for this x plus 3. All right? Now, vertical asymptote. And 0. X equals negative 5 and 0. That's when the denominator equals 0 and does not cross us out from the numerator. A lot of rules to remember. All right, horizontal asymptote. That's based off of the degree. So the degree of the numerator is 2. Degree of the denominator is 3. Since the denominator is greater than the numerator, we have a horizontal asymptote at y equals 0. All right, and now we're going to go ahead and do our domains. Remember, when we're doing our domains, we are not including the wholes, and we're not including the vertical asymptotes. So we go from negative infinity to our first negative at negative 5, and from negative 5 to negative what? Negative 2? Negative 3 is a 0. to 0 for our next vertical asymptote, and from 0 to our hole at 4, and from 4 to infinity. Any questions? You could use the graphic calculator to sketch for G, but I'm going to go ahead and bypass that because we don't, unless y'all really want to do that. No, I got just one. Bypass the sketching. Everyone got this? We're going to go to our example 4. We're going to actually look at a graph and think about what could have been the equation for that graph. All right, everyone got this? Okay. All right, everyone got this? All right. Yes, ma'am? Oh, you got it? Oh, okay. Okay, sorry. Y'all got to remember those rules for that test. All right, you could graph it yourself using the graphic calculator, the Desmos graphic calculator. But let's get to the fun part and create the equations. Yay! All right. First, the graph of rational function f of x is shown above. We need to write an equation in factored form for f of x. We have a horizontal. We have a hole at x equals 4. Excellent.
One of our factors on the numerator and the denominator is x minus 4.
Excellent.
And a 0 at, that's 3.
So x minus 4 for the numerator and the denominator. And you said we have a, what at 3?
0.
A 0. At x equals 3 right here. And that would be if it's a 0 in the denominator, we have a vertical asymptote. But if we have a 0, where does the 0 has to be from? The numerator. The numerator. So what factor is in the numerator? X minus 3. Excellent. We have a vertical asymptote at x equals 2. Excellent. Vertical asymptotes will be found in our numerator or our denominator. Denominator. So what was the factor in the denominator? X minus 2. Because when we set it equal to 0, it gives us positive. Mm-hmm. Yes, ma'am. Mm-hmm. And we have a horizontal asymptote at y equals -1. Excellent. So, what does the horizontal asymptote represent? What does that tell me about the degrees? They're either the same or the numerator is greater. No, the denominator is greater than the numerator. Yes. All right. So since it's a -1 for the horizontal asymptote, then the leading coefficient of the numerator and the denominator is -1. Okay. All right. So let's go ahead and create the equation. Every equation starts with f of x equals, please don't forget that. All right. For our whole, we're going to put that at the top and the bottom. X minus 3 in the numerator. X minus 2 in the denominator. All right, we have all the vertical asymptote zeros and wholes, and now we need to get the horizontal asymptote. That's when the degree of the numerator and the denominator is the same. What is the current degree of the numerator? 2. The degree of the denominator? 2. Since it's the same, we need to make the leading coefficient the same. So I'm just going to add a negative. Wasn't that fun? Any questions? All right, everyone has this? Oh, okay. Okay. Now, everyone got this? Yes? All right, let's go ahead and look at that graph for the next one and see if we could think about what is the equation. This is if g of x. What do you examine? What have you examined? We have a whole at what? X equals 2. So we have a factor at x minus 2. Excellent. That's going to be in the numerator and the denominator. Excellent. We have a 0 at x equals 1. Factor is x minus 1, and that will be in the numerator. Because if it was in the denominator, that would give us a vertical asymptote. Now we have a vertical asymptote at x equals 3. So we have a factor of x minus 3 where? In the denominator. Excellent. And we have anything else? We have a horizontal asymptote All right, we have a horizontal asymptote. This part of the graph gets closer and closer to y equals 0. And this part of the graph gets closer and closer to y equals 0. So we have a horizontal asymptote at y equals 0. So what does that tell us about the degree? The degree of the denominator is greater. The degree of the denominator is greater, so that is the reason why we have a horizontal asymptote at y equals 0. All right, now let's create the equation. This is our g of x. Because of the whole, we have x minus 2 in the both numerator and the denominator. Because it's 0, we got that in the numerator. I knew it was about to come out, though. We have a vertical asymptote at x minus 3, which would be in the denominator. All right. Because we have a horizontal asymptote at y equals 0, the denominator has a greater degree. Okay. And one more thing. All right. And there's one more thing on this one because it's supposed to be a negative rational function. And it's a negative rational function. There it go. Okay. All right. So, because on the right side, as x, on the left side first, as x goes towards negative infinity, our y is going towards 0. On the right side, as x is going towards positive infinity, our y is going towards 0. So, our leading coefficient is -1 because let me see how I can explain this. I would have to end up testing the intervals for that. What you think?
The leading coefficient is negative. I just, wait, no, it might be. Wait. Yeah, it's negative.
But how? How you know?
I graphed it.
Well, there you go. Okay, I got to figure out though, just in case, because I don't know if that's gonna be graphic calculator active or not. I got to figure that part out. Okay.
It, since like the right portion of the graph is coming from the negative, I don't know if it's and it's not going past the negative, and it's like since it's going from it's on like the negative side, but it's going positively, and then on the other side it's like on the positive side, but it's going negatively. I don't know.
Okay. I'm gonna test out on that one a little bit. But yes, beautiful, beautiful. Now on to the next. Oh, that's that slant asymptote. Yeah. Everyone got this? Yes? Given a rational function, if the degree of the numerator is 1 greater than the degree of the denominator, then the rational function has a what type of asymptote? Slant asymptote. That's where the dividing polynomials come in. All right, so the function k of x, they gave us the before it was factored in the factored form. The graph above has a hole at x equals 2. We see that it crosses out in the numerator and denominator. A vertical asymptote at x equals -1 from the denominator. The graph of k of x does not have a horizontal asymptote, but k of x has a slant asymptote. And we need to figure out what the slant asymptote is at. Since the degree of the numerator, 3, is 1 greater than the degree of the denominator, 2, we knew that k of x will have a slant asymptote. To find the equation of the slant asymptote, we will use long division. If f of x and g of x are polynomials, then f of x divided by g of x equals g of x, well, yeah, we ain't even going to do that. Where q is a quotient, r is a remainder. All right, so y'all know the old method of numerical long division. We're going to do that same old method with the new method with polynomial long division. So if we had 676 divided by 21, that old method, or back in my day, we did 21. Yes, ma'am. Now, we had back the old time when we just had two numbers, we had to think of how many times does 21 goes into 67, and that is 3 times. 3 times 21 is 63. And what did we do with this? We subtracted. 67 minus 63 is 4, and we bring down the 6. 21 into 46 is 2. 2 times 21 is 42. We do what with these two? We subtract it, and our remainder is 4. All right? So our quotient is 32. Our remainder is 4. And we could actually state that we could actually create this as a full answer of 32 and 4 over what was already in the denominator, 21. We're going to do that same thing with polynomials, all right? So we have 2x plus 1 on the outside, and we're dividing it into the 6x squared plus 7x plus 6. First thing, how many times does 2x go in the 6x squared? Hmm? 3 times, and how can I get that squared? 3x. All right? We're doing this the same way. 3x times 2x is 6x squared. That 3x times 1 is 3x. Now what do we do? Subtract both terms, which make both of them its opposite on the bottom. So the 6x squared and the negative 6x squared crosses out. 7x minus 3x is 4x. And we bring down the 6. All right? Now, 2x into 4x is 2 times. 2 times 2x is 4x. 2 times 1 is plus 2. We need to do what? Subtract both terms, making everything is opposite. The 4x cancels out. 6 minus 2 is 4. So our remainder is 4. Our quotient is 3x plus 2.
Did we do this to show that, like, if you can long divide, like, an equation normally? Because, like, 6, 7, 6 divided by 21. 6x squared plus 7x plus 6 divided by 2x plus 9. And the remainder is the same. And the quotient is, you just put x in there.
All right, wait. I think I'm missing something. What was that?
They're like the same function in a sense. That one, or I don't know. I don't know exactly how to explain it, but the remainder is the same, and the answer is, in a way, the same. Like the 3 and the 2, 32. It's just like adding in a few x's. And the numbers at the front are the same. 6, 7, 6, 2, 1.
Dang, gone. I didn't even see that. But yes, accurate. I didn't see that pattern.
6, 7.
Sorry. All right. Now, so our answer is 3. Excellent. 3x plus 2 plus 4 over 2x plus 1. What was in the denominator? I'll put this in parentheses. Okay, wasn't that fun? I know it was, deep down inside. All right. Now let's do examples. Oh, we did example 6. Oh, no, we didn't. Okay, let's do that. Everyone got this? My coffee's getting cool. Everyone got this? So, oh, I'm sorry. If you're done copying this down, go to example 6. I want the full answer with the remainder. You're welcome.
Oh, get you on the flip side.
Oh, Lord. Do that long division because it's fun. All right. Oh.
Not a care in the world. Period.
How do we know that it's a slant asymptote for example 6? You said what? By how much? Excellent. The numerator is greater than the degree of the denominator by 1. That's when you automatically do slant asymptote. All right? Everyone got this? Okay. Because I'm ready for the fun. How about y'all? Yeah? All right. Now let's use some long division. Sure. We know we're going to do slant asymptote because the degree of the numerator is 1 degree bigger than the denominator. So we're going to do our 2x plus 1 divided by 6x squared plus x plus 5. First, 2x go into what? 6x squared. How many times? 3x times. 3x times 2x is 6x squared. 3x times 1 is 3x. We're going to subtract both terms. That crosses out this. 1x minus 3x is negative 2x, and we bring down the plus 5. Excellent. That 2x into negative 2x is negative 1. Excellent. Negative 1 times 2x is negative 2x. Negative 1 times 1 is negative 1. We do what? Change the signs because everything turns to its opposite here. That crosses this out. 5 plus 1 is 6. Excellent. So our answer is, well, first our slant asymptote is only the 3x minus 1. Because we still have to subtract this, and since it was negative, it turned to a positive. Since this was negative, it turned to a positive. So we have a slant asymptote at y equals 3x minus 1. And when we divide those two polynomials, we have our answer of h of x equal the 3x minus 1 plus 6 over 2x plus 1. Isn't that fun? I was trying to tell you, it's so fun. I know it tingles. All right. Are y'all ready to do another one? I know y'all are deep down inside, and we are. Okay, dokie. What do we need to do for example 7 first? That's right. See, look at you. I see that. Now, for the numerator, what can we pull out of the numerator? A x, excellent.
No, I was saying it. It just didn't come out. It was like this.
Sure. When we pull out an x, what do we have left?
X plus 6, X minus 2, eventually.
Right. Okay. Oh, you went ahead and factored it. Okay. Well, when we pull out an x first, we have x squared plus 4x minus 12. And then we already had Charles that factored that as x of x plus 6x minus 2.
Yeah.
And the denominator, two numbers to multiply to give us 6, add together to give us 7 is
X plus 6, X plus 1.
x plus 6 and x plus 1. All right. So we have our factored form. Excellent. We have a vertical asymptote. X equals -1. We got that from where? In the denominator. Excellent. All right. We have a horizontal asymptote. What's the degree of the numerator? And what's the degree of the denominator? So do we have a horizontal asymptote? No, we have a what? Slant asymptote, our favorite. All right. All right. So we're going to go ahead and cross out the holes. And all we have is x times x minus 2 over x plus 1. To get the slant asymptote, we're going to have to divide. So we need to actually go ahead and put this back in unfactored form. Don't you love that? I know. I love it. X squared minus 2x. And what's going in there is x plus 1. X going to X squared, X times. We have X times X, which is X squared, X times 1, which is X. We do what? Subtract. That crosses this out.
Happy birthday, girl. Thank you.
Oh, you better.
Thank you. Miss Womack needs to stay put.
Tell Miss what? Oh. I would love to give my coach. It ain't. So we are back like we never left. Where was we have negative 2x minus x is negative 3x. What in the what the? And then x into negative 3x is minus 3. And then, let me see if I can pull it up a little bit. Negative 3 times x is negative 3x. And negative 3 times 1 is negative 3. What do we do? Subtract, which is changing the signs. And we have 3 left. So our slant asymptote is that y equals x minus 3. Wasn't that fun? I know it was. Yes, I know it was. Huh? No, we don't need to. All it asks for is the slant asymptote, so all we need is that part. I did want to go over the remainder just in case, but we don't need it right now. All right. Any questions? Wasn't that fun? I know. So, no, for example 8, we need to see what is correct about d of x. Looking at d of x, what is the degree of the numerator? 3. What is the degree of the denominator? 2, because it's not factored. All right, so 2 for the denominator, 3 for the numerator. Will we be dealing with a horizontal asymptote? Huh? I'm asking.
No.
How you know?
You shook your head no.
Okay, that is a good one, good answer. But let me erase this. Let me pull up and we're gonna get it. We're gonna get a mathematical. Oh, okay. I'm sorry. This math get me excited. The highlight of my day. I have a pass order. I'm waiting for that answer for example 8. Why is it not a horizontal asymptote?
So all these oh, it's not in the division part for the third line under x squared plus x.
Right here? Negative 3x. Yes. Oh. The question was, why in example 8 are we not dealing with a horizontal asymptote? Can you say that a little bit louder, Vanessa?
The degree of the numerator is
Excellent. The degree of the numerator is 1 degree higher than the degree of the denominator. So we're dealing with a slant asymptote. All right, everyone got this? Everyone got this part? All righty. So since we're dealing with a slant asymptote, we could go ahead and eliminate which two? A and B. And you said the answer is C? All right. In order for us to see that, what would we need to do? Because the only thing difference is one got a hole and one doesn't. So what do we need to do to figure out if that is correct? My favorite thing to do. All right. So we got the top already factored, 2x, x plus 4, x minus 1. We need to factor the denominator. Two numbers that multiply to give us 1, add together to give us -2. Excellent. So do we have whole? Remember the rule. Remember the rule. It has to cancel all the way. Huh? The denominator. Does it cancel out all the way in the denominator? No. So do we have a whole? No. So the answer is D. Thank y'all. Because it has to cancel out all the way in the denominator. We still got another x minus 1 down there. So it's not a whole, but vertical asymptote. All right. And okay. And y'all could do the sketching. I'm going to pass by that, if y'all don't mind. I just want to make sure, because if y'all want me to do the sketching, I will do it. Y'all need me to do the sketching? You sure?
Yeah.
Y'all sketching though? Huh? Do it? Okay, sure. Sure. Y'all got all this right here? All right. All right. So as x approaches, we're going to have a vertical asymptote at -1. So vertical asymptote at -1. As x goes towards infinity, our y goes towards -infinity. All right. All right. Am I missing anything else? All right, let me do this one. Yeah, let me first work towards the vertical asymptote. As x goes towards -1 from the negative, that's this way, our y is going towards -infinity. All right, so that will be going down. As x goes towards -infinity, our y goes towards infinity. So that part would go up. as x goes towards -1 from the positive, our y goes towards -infinity, so that would go down.
So does the dotted line go to number one? The second line or
Uh,
that one goes to number two, the one you just drew is for number three.
the vertical asymptote comes from these limits right here.
Okay.
So as x goes towards -1 from the negative, it goes towards -infinity. I started there. As x goes towards -1 from the positive, it goes towards -infinity here. And then the infinities. As x goes towards -infinity, my y goes towards positive infinity. That's number 2. As x goes towards positive infinity, my y goes towards -infinity. Any questions? All right. Gosh, we're using all our time up. Oh well. Oh, we did this part already, didn't we? Yep. And did y'all answer example 10, 11, 12, and 13 already?
We didn't do
12 and 13? I would love to. we did 13.
We did not do 12 and 13.
We did not 12 and 13. All right. Everyone got this? Let's do 12 and 13. What is the coefficient of the term containing x to the 4th when the expression is x plus 5 to the 6th? Can I have someone rewrite my Pascal's triangle? Go ahead up here, Vanessa, because you got to know how to do it by heart. All right, just do it the long way. Oh, Charlie. Yes.
Multiplying it out.
Mm-hmm. Mm-hmm. Excellent. Excellent. Beautiful. Now, we're looking for the coefficient of the term containing x to the 4th. This is our at 6th level. So this would be x to the 6th, x to the 5th, and this will be our x to the 4th. So remember with our x to the 4th, so we don't have to do it the long way, we have 15 x to the 4th, and we have this 5. Remember, the 5 goes backwards. That's 5 to the 0, 5 to the 1, and 5 to the 2. Yes, ma'am? Oh, okay. All right. Now we could just get the leading coefficients. 5 squared is 25 times 15. Oh no, we're still using the fourth term. So x to the 6th, x to the 5th, x to the 4th. So that is 25 times 15, which equals 375 x to the 4th. And we ain't have to do all that distributive. Now let's do it again. All right. We're on to the 8th power. Woo! Okay. Oh. While these technical difficulties is going on, it's the 8th. Yay. Yay. Okay. Oh, Vanessa, you come on up.
I stopped at row 6, right?
Yes, ma'am.
That's up our first. I don't like doing the Pascal function, so I do it through course. Miss Bailey, do we have any homework?
I want y'all to work on that. That delta math is easy. I want y'all to look at that AP questions.
The questions in AP class.
And that's on all of Unit 1. Whatever y'all did not get from that, we need to figure out what it is so we could go over it. Don't forget to sign in. All right, and as always, we're going to cut it off here while Vanessa's finishing it up. I can. I said I can. And I know you can. So please subscribe below.
Period. That's right, we're gonna grab your mama.